Having dealt with commercial construction, we need to talk about home construction, which of course changes dramatically in the 19th century as well. Now, whereas commercial construction is using what's called skeleton frame, in other words, building the steel skeleton and then building the building around it, where you have an exterior clad in stone and glass in the 19th century and an interior clad with plaster and then with eventually drywall. That works great for commercial work, but of course with homes it's going to be different. So we're going to see what's called balloon framing in homes, which is effectively a skeleton frame translated for wood. And the advantage here is balloon framing is based on using metal fasteners, plates, and nails to put it together. It means I need less skill to do so. It also makes it cheaper because I don't need to spend the time creating mortise and tenon joints for every piece of woodwork. There's no special joinery, nothing else. I can show up with a load of 2x4s and 1x8s or 2x8s or whatever it is, and I can build a house. Balloon framing is actually a derogatory term that they came up with at the time because no one thought these houses would survive. They thought they'd be blown down, etc., because they're very lightweight. They rely on the exterior cladding and the interior walls to help give some support to the frame. And it looks like something that would easily topple over. So you can imagine how people were kind of nervous about this idea, but it catches on. So here we see a comparison in our traditional European construction, here sort of Elizabethan Tudor construction. You'll notice that everything is highly skilled. All of these joints have to be put together with mortise and tenon. They're curved elements, they're braces and trusses. The whole thing takes a great deal of skill. I need a very skilled workforce to build one of these. Whereas balloon frame is much more straightforward. Now, whereas here we have really heavy supports and not very many of them, because of course I don't need that many of them. They're big, they're heavy, they're well joined. In balloon frame, we need considerably more framing. But the advantage is it ultimately is lighter and, again, cheaper, which means more people can start to afford homes and it expands from there. Now, this is also a point where I need to bring in the issue of load-bearing and non-load-bearing walls. Now, in traditional construction, most walls are not load-bearing. Most of the weight is running through either a central wall or through the outside four walls of the structure. As we get into balloon frame, of course, that's no longer the case, and we start to see the issue of load-bearing walls. So, for example, as we move down, we have certain walls that will be load-bearing and certain walls that will not. This wall is not load-bearing at the top because it is only holding the roof, which is really held perfectly well by these walls on the outside. But by the time you get to the first floor, all that weight that has built up from the second floor and the roof is now too great to just travel down these exterior walls. So we need a central brace in the form of a load-bearing wall. Generally, if the wall is running perpendicular to the roof trusses, I would assume it's load-bearing. Also, if there's a wall directly above it on the upper floor, then there's a good chance. In the basement, that's why you tend to see these metal columns. Those are holding up a bearing beam, and that's why you don't want to swing around it if you happen to be at an intergalactic kegger in someone's basement, because you could accidentally do that, which is what happens when you remove the wrong load-bearing wall. Just think about that for a moment. Make really sure that if you remove a wall, it's not load-bearing.